Alright guys, so we're going to do the last two examples, and then we'll leave the jerk theorem for class. So the quiz could possibly be moved to Thursday, but we'll play it by ear. I'm not 100% sure right now because the jerk theorem is not that different than what we're doing right now. Okay, so let's start off. So if y equals tan of x over the interval negative pi over 2 to pi over 2, find the equation of the tangent line, which basically means find the equation for the slope of this guy's derivative. So what is the derivative of tan of x? We now know is secant squared of x. Okay, so m, the slope, at x equals pi over 3 is, so secant squared of pi over 3. You plug that in the calculator, and we get 4. Or you don't really have to, well, yeah, we'll plug this in the calculator because it is squared, but you really don't have to if you know your unit circle and you know that secant is the same thing as 1 over cosine, but then we're going to square it. So you end up with 4. So this guy is our slope. So that's our slope. And now that we have our slope, all we need to do is find y equals mx plus b for this problem. So we know our slope, we know our x. The question is what is our y? So how do we find our y? We take our x, right, and plug it back into the original equation. So y is equal to tan of pi over 3. So y is square root of 3. So now that we know our 3 parts, we can set up square root of 3 equals 4 times pi over 3 plus b. And I'll let you guys finish this up to get y equals 4 times x plus what is b. Okay? And we'll check our answers in class. All right. Next problem, does y equals 2x plus sine of x have any horizontal tangents on this interval? So remember, whenever it's asking, does it have any horizontal tangents? Horizontal tangents is when m is 0, aka it's when the derivative is 0. So we want to figure out where is y prime 0. In order to do that, we first have to find the derivative of this. So what is the derivative of 2x? It's 2. And then what is the derivative of sine of x? Is cosine of x. And the question is where is this guy 0? So 2 plus cosine of x is 0. So you solve it. Cosine of x equals negative 2. Now remember, how do we figure out x when we know this guy? We use the inverse. So inverse of negative 2 is what? So the question is where is cosine of x negative 2? So we're going to use the calculator. We're going to do the inverse cosine of negative 2, and you get a non-real calculation, which means, is there a horizontal tangent? No horizontal tangents. Because the only place that it can be 0 is when x is negative 2, and when y is negative 2, and for this specific function, it's out of the domain, right? Because cosine of x will never be negative 2 because cosine of x its highest and lowest points are 1 and -1. So no horizontal tangents. Okay, so I'm going to leave you guys with the definition of a jerk. No pun intended. Okay, a jerk, think of it like a car in the car. When your car jerks, it's basically a sudden change in acceleration. So it's the derivative of acceleration. If a body at time t is s of t. So what that means is the body's jerk at time t is j of t equals the derivative of acceleration. Now you remember, velocity is the first derivative, acceleration was the second derivative, therefore the derivative of acceleration is going to be the third derivative. Alright, so I'm going to leave you with this, and I need you guys to fill this in. So recall the Pythagorean identities for sine and cosine and tangent. And we'll do the special angles in class, and we'll leave the last two examples. We'll do them in class. Okay?